Hello Year 12, welcome to another video here. I'm sorry this is a little late and we've gone dark. I'm looking pretty scruffy, you don't need to see that. Now, we have talked about this a little bit in class, the exponential function. If I use this definite article, the exponential function, I suppose I'm really talking about y equals e to the power of x. E being Euler's number, about 2.7-ish, some magical number. And it's sort of magical in the sense that if I differentiate the exponential function, y equals e to the x, the derivative is equal to the function. Right, that tells me that the gradient of that function is always equal to the value of the function, wherever I move. X equals, so the gradient is always the same as the value of the function. And we can then sort of complicate matters and vary that formula a little bit. I suppose we could talk about transforming that a little bit, and we've still got that property to fall back on. Right, we can fall back on that property that the derivative of e to the power of x equals e to the power of x. Wonderful thing. Now, we also talked about this in class a little bit, that maybe we could be asked to do this. It's unlikely. I don't know what's happened there. That's a silly question. But, you know, who knows? You'd be silly to lose the marks on this if you're asked to do such a thing. So let's say, correct to 4 significant figures, what is the value of e? Maybe you remember, but I don't. So I pull out my calculator. This is a fair bit like the sharps that most of you are using. So I'm going to say, right, you can see e to the x here. So second function, e to the x to the power of 1. That's going to do it for me, right? 2.718 for significant figures to 2.718. All good? Yeah. And 1 over e, well, we can do that as well. Let's just see how that goes. Grab my calculator again. This time I'm going to go, that's the same as e to the negative 1. Let's clear that. E to the power of negative 1 equals 0.3679. Right, square root e to the half. You know, that's straightforward enough. You can work that out. It's pretty easy so far. Yep, that's why we raced through it in class, because, you know, it's just not that complicated. We can do transformations. These work the same as the transformations that you've done in functions all the way back early in year 11. Okay, so I can shift things parallel to the y-axis. I can shift it parallel to the x-axis. I can reflect it in the y-axis. I can reflect it in the y-axis. I can reflect it in the x-axis if I want to. Anyhow, that's fine. So we can do those things here. Let's have a look. We'll see how these transformations work. If we have y equals e to the x plus 3, it's asking us to fill out a bit of a table of values. See how that goes. Look, that's always a reasonable fallback option. If you are really stuck and you've got a calculator, you could plug things into that equation and see how it's looking. So I'm going to say that this is going to be x and y, and this is going to be an approximate value of y. Okay, so if x equals, let's try -1, 0, and 1 for this. All right, that should get us there. So we're going to have e to the power of -1 plus 3. There's not really a good way to write that. I could say 1 over e plus 3. It's not very good. But punch that into your calculator and you're going to get about 3.37. You're going to get something. Now 0. Well, that's e to the 0, which is 1. 1 plus 3 is 4. Right, that is not just approximately equal to 4. That is equal to 4. And now if I plug a 1 into this, e to the 1, that's e plus 3. Right, e plus 3, and that's going to be about 5.72. Right. So we've got to sketch this. We need the y-intercept, the horizontal asymptote, and the range. That's what it's asking for here. A bit of a tip. Easiest to get a good sort of match. Draw your exponential first. Looks something like that. Ooh, that's been a very good asymptote. Now I'm going to rub that out, because I really need to get something that looks a lot like an asymptote, and then it can rise up there. Now, we have y-intercept, right? When x equals 0, y equals 4. And I have an asymptote here, right? Because as small as that gets, if x becomes if x approaches negative infinity, right down that way, that becomes pretty close to 0, so the whole lot becomes fairly close to 3. So my asymptote, oops, my pen doesn't want to work, is along here at 3. Right, and there is my x-axis. Righto, so we look something like this. Now, what does it want? Y-intercept. Y-intercept is at 0, 4. The horizontal asymptote. The horizontal asymptote is... Whoa, whoa, what's happened there? Something magic's happened. YouTube, come back. The horizontal asymptote is y equals 3, and my range, y is greater than 3. Right, greater than the asymptote, that's fine. First one, let's have a look over here. It's a little different. Let's say x, y, and an approximate y. And this time, because we've got x minus 2, I don't want to start down the negative, so it's going to take me back there anyway. So let's go with 0, 1, 2, and then just for good measure, I'm going to put 3 on there as well at the end. Righto, so 0 minus 2, e to the negative 2, right? Or 1 over e squared. E to the negative 2 is approximately 0.14. Now, e to the 1 minus 2, e to the negative 1, e to the negative 1 is approximately equal to 0.37. Yeah, 37. E to the 2 minus 2 is e to the 0, which is 1. Great, it's probably important we put the 1 in. And to the 3 minus 2 is e to the 1, right? So that's just e, and of course that's approximately 2.72. Righto, now, x equals 0, y-intercept 0.14. What we've really done this time is, so this one here, we have, that's like y minus 3. We have lifted it up 3 units. This time what we've done is we have shuffled the graph 2 units to the right, okay, which brings us down more into this territory. So we still get the same looking curve like this, but this time my intercept is sort of, I'm going to draw that asymptote in, which is going to be, oops, I shouldn't draw it like that, because that is my x-axis, isn't it? Right, it still does that, it's just that, where it normally, right, if it's just y equals e to the x, when x equals 0, y equals 1, so we usually get the y-intercept at 0, 1, this time we get at 0, this little number here, so it's down here somewhere. So you've got x and y labelled here, that's 0, oh wait, I should describe that, not a 0.14, that's silly, that's an approximation. We should say that's e to the negative 2. That's my intercept there. My asymptote is here, that's about all there is to label, so we say the same things. That's what I asked for. Y-intercept is at 0, e to the negative 2. And my asymptote is y equals 0, which is the x-axis, and the range of this function, y is strictly greater than 0. Righto? All good? That is the exponential function. A couple of little things to remember there. Look, it's a scrappy little unit, little exercise. I think that one, we did move through it quickly. But if you want to refer to these things, if it clears things up at any stage, that's wonderful.